Hey everyone, so I'll be showing you my tree project. So we have McKenna Hansen's tree project, and this is for the Fall 2020 Biology 101 lab, and I am from the Tuesday 9 a.m. section. So for this project, what we did was collect data and took pictures weekly of the trees that we chose on our own just to find out how they change over time with weather and everything like that. So my hypothesis is if tree 1418 is smaller, then I expect it to change colors first before tree 1416. So I took photos of my two trees weekly and assigned them a numerical value to each one using the chart to the right. So I studied tree 1416, which is a green ash tree, and I also did tree 1418, which is an apple tree. These trees are located right on campus here, and they're located on my walk back to the dorms after class in Jonas Academic. And I would visit these trees about once a week from the time between September to October. And to determine the leaf color, I use this leaf color chart here on the right side of the screen. So now I'll go through all my photos and show you the results I got. Here's the pictures from week 1 on September 2nd. On the left we have the green ash tree, and on the right we have the apple tree. The green ash I put is about at a 1.2 because it's still very green, and then the apple tree I put a 1.4 and a 9.3 because as you can see there's like green in it, but there's also some reddish color, so that's why I gave it the 9.3 as well. For week 2, I did it on September 7th. On the left, again, we have the green ash, and I gave it a 1.4 because it's still very green and vibrant. And then on the right, we have the apple tree, and I gave it a 1.8 because there's still some green, 2.7 because you can start to see some yellow coming through, and then again a 9.3 because you still have the reddish leaf colors in there as well. And then for week 3, I did it on September 18th. And the green ash one is still very green and vibrant, so I gave it a 1.5. The apple tree was a whole bunch of colors. I gave it a 2.5 for the green in there, 3.8 for some of the yellow oranges peeking through, and then a 9.3 again for still the reddish colors that remain in there as well. Week 4, I did it on September 29th. On the left, again, we have the green ash tree. I gave it a 1.5 because it's still very green and vibrant and healthy with the weather we're having then. And then the tree on the right, the apple tree, I gave it a 2.1 because there's still green, and a 9.3 because you can still see the reddish colors remaining in there still to this day. For week 5, I did it on October 5th. The green ash tree is very vibrant green and some yellows peeking through, so I gave it a 2.4. And then on the right we have the apple tree, which I gave it a 4.6 for some of the orange yellows in there, and then still the 9.3 with the reddish maroon leaves still at the top there. And then for week 6, I did it on October 14th. This was a huge change for the trees with the snowfall we had. So then we have the green ash tree, which is now a 4.3 with a lot of like orange and yellow leaves, or just the leaves being gone in general. And then the apple tree, I gave it a 9.5 because if there are any leaves, they're mostly reddish on there, a couple orange. Otherwise, they're gone because they have all died off with the weather we went through. So my conclusion is that the data I collected does support my hypothesis because the smaller tree, the apple tree that I collected data for, changed colors a lot quicker than the green ash tree because they thus dying off faster. tree 1416 stayed alive and vibrant a lot longer than tree 1418. So therefore, my hypothesis does support my data. Because a smaller tree changed colors a lot faster and died off a lot faster than the bigger tree did. So that was my tree project. I thank you for listening. And yeah.